So today we are going to discuss about maxima minima. This is the last topic of third module, maxima minima of maxima minima of a single variable function. Same type of problems are also we are going to study in the fourth module also. But in the fourth module, two variable functions, maxima minima of two variable functions. Here maxima minima of single variable function. Module 3 we are discussing about single variable function. In module 4 we are going to discuss about two variable functions of maxima minima. So now maxima minima in the third module, single variable function. Single variable function means f of x. X is the independent variable. Function depends on only one independent variable. It's called a single variable function. Here f of x is said to have a maximum value at x equal to a if there exists a smallest number. That means as per graph you see maximum minimum function value. In elementary section in our childhood, just substitute the input values. For example, this is a curve. You see here we have a maximum, reach some maximum point, increases the curve after reaching one maximum point, peak point, and then decreases. In corresponding neighborhood, in the small neighborhood of this point, this is the peak maximum value. Maximum value means its image value. This is image value. For example, this is say C, f of C, image value. So it's a neighboring point, left side neighboring as well as right side neighboring. Both are less than f of C. That means there exists a neighbor. In the neighborhood means in the left side means C minus delta. Subtract some value, we get a left side value. Add some positive quantity to C, we get a right side value. At this point, corresponding function value is f of C plus delta. At this point, f of x value is C minus delta, f of C minus delta. My graph is not clearly drawn. You understand that at peak, we have a maximum y value. In the neighborhood, either left side as well as right side, this is less than corresponding y value is less than the previous value. So this point, at this point, the function, we say that the function has a maximum. Similarly, minimum, you observe that here. Graph is decreases, reaches to some minimum value, then increases. So decreases. After that, increases. The point at which the phases changes, decreases to increases. That means negative to positive. Here positive to negative, increases and then reach and then decreases. Here positive to negative, here negative to positive. At the point the curve nature changes, positive to negative. Okay, so here this is the way to understand the concept of maxima minima. So basic definition is a function. You must remember these definitions because in your exam pattern we have a 2 marks questions also. That time we may ask definitions. Define a maximum value of a function at x equal to a, or define a maximum of a function. That time you must remember and write down this answer. A function f of x is said to have a maximum value. Simply maximum. Maximum means maximum value at x equal to a. At x equal to a, if I need to share the screen. Please see. A function f of x is said to have a maximum value at x equal to a if there exists a smallest neighborhood h, c in the previous. Here I am taking delta instead of h, I am taking delta. C minus delta, C plus delta, neighborhood of C. At these corresponding points, the function has a smaller than small values, image values, that means y values. F of a greater than both f of a minus h and f of a plus h. Then that means f of a is maximum in the neighborhood. Therefore, the point x equal to the point at x equal to a, the function is said to be have a maximum. Similarly, minimum value. Minimum means f of a less than the neighboring points. F of a minimum means comparing with the neighbor only. We say we are a bigger either size. As per size also we are bigger, smaller weight. Our weight is heavier than our neighbors property. Likewise here also take a point, take the neighborhoods left side and right side. Observe that their corresponding points have more than the function value. Then that value is said to be minimum value at the point given A. This is the maximum minimum of the functions. So the corresponding points, the function which have a maximum minima are called extreme points, extreme values. Maxima minima also called extreme value. Extreme value means either maxima or minima. At the point we occur a maxima or minimum. At the point we get a maxima or minima are called turning points. Here A is called a turning point. F of A are called extreme values. F of A is called extreme value. The point A is called turning point. Turning point means from that point only the graph of nature is changes, positive to negative or negative to positive. That is the definitions. 2 marks questions will come from these definitions in this unit. You must remember these definitions. Next, procedure for finding maxima minima. You remember that I think everybody knows this process, or a single variable. In BSc level also this kind of problems are available. Most of the BSc standard books contains these kind of problems because you are undergraduates, already completed undergraduates. So mostly, you know, take a function f of x. Suppose, for example, x square plus y square, x square minus 2x plus 1. You take that value equal to f of x. Take given value equal to f of x. First step. Next step, find the derivative. After finding derivative, find roots of the derivative. F dash x. Then equate to 0 and solve it. Find its roots. Suppose it is a quadratic equation, derivative is a quadratic equation, we get 2 roots. If it is a cubic equation, that means order 3, we get a 3 roots. Suppose, for example, f dash x is a quadratic equation, that means 2 roots, a comma b are exist. After that, find a second order derivative, f double dash x. Substitute each root. First time substitute a in f double dash x. If f double dash a value is less than 0, less than 0 means negative, then we say that the function is said to have a maximum at the point x equal to a. Maximum value is f of a. F double dash a is positive, then f of x is said to have a minimum value at x equal to a. The corresponding minimum value is f of a. After verifying at x equal to a, next we start from at x equal to b. At x equal to b, substitute b in the f double dash derivative. You always remember that first step, f of x equal to given function. Find the derivative, second step, and find its roots. Second step. After that, finding the roots, substitute each root in f double dash x. Find f double dash x and substitute each root in f double dash x. At the root, at the corresponding root, f double dash x is less than 0 or greater than 0, you observe that. If it is less than 0, we say that the function has a maximum value at x equal to given point. If it is given point means nothing but a root. At the root, f double dash a is f double dash x is positive at the root value, then we say that the function has a minimum value. This is the procedure. Maybe function derivative value may be 0. Sometimes second derivative may not exist. That time we required further investigation. This is the note point. No need to remember these things. I will explain you. Further investigation is required means by the graph only we can understand whether it has a maxima minima. If these conditions are failed, that means after observing f double dash a, it may be greater than 0 or less than 0. Sometimes it may be equal to 0. It may be equal to 0. That time we can't say anything. That time further investigation is required. Further investigation means by the graph nature, we can decide whether it has a maxima or minima. Sometimes it may not have a maxima minima also. Based on the graph nature, we can decide. So immediately we are going to solve the problems. Here I am providing 3 problems. In this class, we will solve these 3 problems. This section is also important. Don't leave it for the examination point of view. You must read all these questions. Okay. So start the first problem. Okay. First problem. Here the problem is f of x equal to first step, first problem, problem 1. Not here. It is better to write down. Problem 1, solution. Problem 1, first write down problem. Problem 1, solution. First step is let f of x equal to given function. Given function is 3x power 4, this expression. Okay, this expression 3x power 4 minus 2x cube minus 6x square plus 6x plus 1. Here domain is, that means x is taken in the from where x is taken from 0 to 2. Don't take other values. You always take x value from 0 to 2, open interval. Does not include 0, does not include 2. In between 0 and 2. 0, 2. We have 1 is there, 0.1 is there, 0.5 is there, 0.1 is there. All the points lies between 0 and 1. So second step is find its derivative. Now f dash x. Its derivative is 3 times of 4 into x power 4 means 12 x cube minus 6x square. 2 into 3x cube means 3 times of x square. Total 2 into 3 means 6 minus 12x plus 6. One derivative becomes 0. It is better to give a equation number 1. Now 6 is a common factor because in each term we have 6 as a common factor. 2x cube because we need roots f dash x equal to 0. In the second step, step 2, we make step 2. This is step 2. This is step 1. Step 1. Step 2 is find f dash x. It is better to simplify the expression. Later make this value equal to 0. See, from this you take x square is a common factor. 2 minus x. From the last two term you take a minus 1 as a common factor. So 2x minus 1. Okay. So by the factorization rule, 2 minus x is a common factor. Here also I made a mistake. 2x minus 1. Because x square is a common factor. In the first term, we left with the 2x. So this become x square minus 1 into 2x minus 1. Take or solve f dash x equal to 0. Solve f dash x equal to 0. That means this value equate to 0. This value equate to 0. That means 6 times of x square minus 1, 2x minus 1 equate to 0. 6 is never be 0. Therefore, other two factors should be 0. Either first factor should be 0 or any one of the other two factors should be 0. This is a quadratic equation. It has two roots. It is written as x minus 1 into x plus 1, a minus b into a plus b. From this, we have x value is 1 by 2. From this expression, any one of them is 0. Either x minus 1 is 0 or x plus 1 is 0. Already we know the last value, x equal to 1 by 2. From this, x value is 1 or x value is minus 1 or x value is 1 by 2. We have three roots because it is a cubic equation, but one lies between 0 and 1, 0 and 2. Our given interval is 0, 2 domain value, but minus 1 does not belongs to 0, 2. So this is lies between 0, 2. That means you don't consider this case. Therefore, let a equal to 1, b equal to 1 by 2. Let be the roots of f dash x in the interval 0, 2. Now third step 3 is find its derivative. I mean second derivative, f double dash x. Second derivative. You observe the first derivative and take a one more derivative for the second derivative. We get second order derivative. 12 into 3, 36x square. First term is 36x square. Next term is 6 into x square means 12x minus 12x. Next term in the derivative is minus 12 into x means minus 12. Minus 12. Take 12 as a common factor. Minus 3x square, x minus 1. Don't bother about the factorization of this. Just substitute the values. At a equal to, we need to test at these 2 points, a equal to 1, b equal to 1 by 2, at these two roots. At a equal to, verification at a equal to 1, whether it has a maxima or minima or neither maxima nor minima. F double dash a equal to f double dash 1. What about f double dash 1 value? Which is equal to 12 times of 3 into 1 square minus 1 minus 1, which is equal to 12 into 3 minus 2, which is equal to 12. 12 is positive greater than 0. Therefore, as per our procedure, therefore f of x has a minimum value at x equal to 1. Therefore, or thus the minimum value is put f of x equal to 1. F of 1. In the f of x, we put x equal to 1 because at we are testing at x equal to 1. 3 into 1 power 4 minus 3 minus 2 minus 6 plus 6 plus 1. 3 into 1 power 4 minus 2 into 1 cube minus 6 into 1 square plus 6 into 1 plus 1. 3 minus 2 minus 6 plus 6 plus 1. Here this value is plus 1 plus 1, which is equal to, this is the minimum value of the function. At one point already we verified at a equal to 1. Now another root is also there for f dash x, b equal to 1 by 4. Now we are going to test. This time take test at or verify at b equal to 1 by 2 because it is also a root of f dash x. That means you substitute b value in f double dash x. F double dash of 1 by 2. F double dash of x value is this one. That means 1 by 2. You substitute 1 by 2. 12 into 3 times of 1 by 2 whole square minus 1 by 2 minus 1. Which is equal to 12 times of 3 by 4 minus 1 by 2 minus 1. Take LCM 4. 3 minus 2 minus 4. That implies 12 into 3 minus 6 minus 4. 12 into minus 3 by 4. 4 4 ja 4 3 ja, which is equal to minus 9. We get the less than 0. That means at 1 by 2 we have a function maximum value. Therefore, f of x has a maximum at x equal to 1 by 2. The maximum value is substitute x equal to 1 by 2. Maximum value is f of 1 by 2. F of 1 by 2 means in the function f of x, we substitute x equal to 1 by 2 in the both side. The given function f of x is 3x power 4 minus 2x cube minus 6 into x square plus 6 into x plus 1. Substitute f of x value. That means 3 into 1 by 2 whole power 4 minus 2 into 1 by 2 whole cube minus 6 into 1 by 2 whole square plus 6 into 1 by 2 plus 1. LCM becomes 2 to 2 power 4. 2 power 4 means 16. Here 3, here 4, here 24, here 48, here 16. Simplify this expression. Here we have two negative terms, minus 28, 48 plus 3, 51, 51 plus 16, 67, 67 minus 28 by 16, 67 minus 28, 7, 8, 9, 5, 2, 3, 39 by 16. This is the value at 1 by 2. This is the maximum value. Previously, we have minimum value at 1. The minimum value is 2. Now, what about this? 32 16 ja 2 times 32 point something. That means this value is 2 point something, more than 2. Therefore, it is a maximum. So, the maximum value is this one. Next problem. Find sin x into 1 plus cos x. Here, read the problem. Second problem. It is better to copy and paste. Show that means already they give the answer also. The function has a maximum at x equal to pi by 3. Show that answer. First step, let f of x equal to, you always take given function. If here you observe that it is a function of x, therefore we take it as a f of x. If it is a function of theta, if we take a f of theta, f of x equal to sin x times of 1 plus cos x. Second step, immediately you find derivative. Now the derivative of the function f of x is, therefore f dash x is UV rule, first function derivative into second function plus second function, first function into derivative of second function means 0 minus sin x. Simplifying this, we get 1 plus cos of x, cos x times of 1 plus cos x minus sin square x. You converted into, because we need a roots, therefore because we need a roots, therefore it is better to simplify the expression. Sin square x equal to 1 minus cos square x. Cos x 1 plus cos x minus of, this is written as 1 plus cos x into 1 minus cos x, because a square minus b square equal to a minus b into a plus b. 1 plus cos x is a common factor in the both the terms. Take it as a common factor. Cos x of 1 minus cos x times of 1 plus cos x. You simplify this expression, it becomes 2 cos x minus 1, 1 plus cos x. Equate this expression equal to, next in the second step, after finding derivative, find its root. Find roots of f dash x equal to 0 or solve f dash x equal to 0. Both are same. Solve f dash x equal to 0. That implies substitute f dash x value. This is f dash x value. 2 cos x minus 1 times of 1 plus cos x equal to 0. From this, actually no need to find, even though it is better to find, I will give the answer. Either any one of the factor is 0. 1 plus cos x is 0. From the first factor, you understand that cos x equal to 1 by 2. From the second factor, cos x equal to minus 1. Cos value is 1 by 2 at pi by 3 at 60 degrees. Cos x equal to minus 1 at x equal to pi. At x equal to pi. So we have two roots. But in our problem, they ask only at pi by 3. No need to find pi by 3 values also. No need to find this step. If the question asks like this, no need to find this point. Simply they ask like previous problem. That time you must find this value also. Suppose they ask find the maximum minima of like previous problem. Previous problem means simply give the function, given the function, find maxima and minima value of the functions. Likewise here also they may ask find the maximum minimum of the function. That time we must be find f dash x equal to 0. That means solve f dash x equal to 0. Find roots. So that means no need to find this value. Already they provide the value also. So now third step is find the second order derivative of the given function. Here the expression is this one, given expression. If you take any one, this one or this one. So, or this one also you can take. Last one. First function into derivative of second function. 2 cos x minus 1 into derivative of second function means minus sin x. Plus second function means cos x plus 1 into derivative of first function means minus 2 sin x. Simplify this expression. Otherwise, no need to simplify. Just now substitute the value. Now at x equal to pi by 3, f double dash of pi by 3 is 2 cos pi by 3 minus 1 minus sin pi by 3 plus cos pi by 3 plus 1 minus 2 sin pi by 3. If this value is negative, then the function must have a maximum. So our question also give the answer. So that means so that the function has a maximum. That means we must show that this is negative. So cos pi by 3 value is 1 by 2. 2 into 1 by 2 minus 1 into minus sin pi by 2. Sorry, pi by 3. Pi by 3 means sin pi by 3 means root 3 by 2. This is the first term value. In here, the second term value is 1 by 2 plus 1 into minus 2 times of root 3 by 2. Here, minus 1 plus 1 becomes 0. This term 0. In the second term, we have a negative 0 minus 2 times of 3 by 2 root 3 by 2. 2 get cancelled. Finally, we get minus 3 root 3 by 2. It is negative because it has a negative sign. Therefore, the given function f of x has a maximum at x equal to pi by 3. No need to verify at pi. No need to verify at pi. If you have any special interest, we can also verify at pi. But at pi, x equal to pi, the derivative, second derivative value 0. Substitute at x equal to pi, f double dash pi value is, see the derivative value. This one, second derivative, 2 cos of 2 cos pi minus 1 minus sin pi plus 1 plus cos pi into minus 2 sin pi. Sin pi value 0. 0 into anything equal to 0. This is 2 minus 1 plus 1 minus 1 into minus 2 into 0. So this value 0, this value 0, derivative is 0. So further investigation is required. Further investigation is required. Because the second derivative is less than 0 or greater than 0, then only we can decide. Otherwise, we can't decide. Further investigation is required. So see at pi, at pi, observe the f dash x value. Observe the f dash x value. Whether the sign changes positive to negative or negative to positive, then only we can decide. This kind of problems in your examination, no, mostly they can't ask you. If they ask, you simply write down and leave it. Further investigation is required. No need to write down, verify at this point. Next, last problem in this topic. Very interesting problem, but a small problem, very interesting problem. Find a and b if the function has a maximum value, extreme, not maximum. Extreme means either maximum or minima at the point x equal to. See, this is the problem. Immediately you here f of x value provide a by x plus b by x. Answer. Now f dash x minus a by x square plus b. What is the roots? Second step, solve. Second step, take f of x equal to first step. Already they provide. Second step onwards, you must start f dash x, find f dash x immediately. And solve f dash x equal to 0. Minus a by x square plus b equal to 0. Already they said at x equal to we have a maximum value. That means x equal to 2. The derivative value is 0. That means a minus 2 square plus b equal to 0. Since they give the x value, x equal to. From this equation, we get a relation between a and b. From this equation, you simplify, you move this term to the right hand side, it becomes a by 4. Take a cross multiplication, we get a equal to 4 times of b. 4 times of b. Substitute in the given function because they provide another value also. Given the hypothesis f of 2. By putting 2, we get a value 1. That means a by 2 plus b equal to 1. A by x plus b into x. Sorry, b into 2. B into x. Yes. X value is 2. But we know the a value in terms of b. That implies 4b by 2 plus 2b equal to 1. 2 2 2 2. Since already we find the a value in terms of b here. Substitute here. Find first b. Later we substitute. From this equation, later substitute here, we get a. What about 2b plus 2b equal to 1? 5b equal to 1. That implies b equal to 1 by 5. Substituting b equal to 1 by 5 in this equation, we get a value. A by 2 plus b into 2 equal to 1. Substituting b value, b value is 1 by 5 into 2 equal to 1. That implies a by 2 equal to 1 minus 2 by 5. Take LCM 5. 5 minus 2, we get 3 by 5. Take a cross multiply, we get a equal to 6 by 5. Therefore, the function f of x is a by x plus b by x equal to 6 by 5 by x plus b value is 1 by 5 into x. That means that is further you simplify, 6 by 5 is common, 6 by 5x plus x by 5. This is the function. Don't stop here because they add one more word in the question. Has the extremum value at x equal to. Is this point a point of maximum or minimum of the graph of f of x? That means you find second derivative and substitute the x equal to. Now f dash x becomes, this value becomes minus 6 by 5 x square plus 1 by 5. f double dash x, because we required f double dash x. F dash x equal to 0 is not necessary, because already they provide the root. F double dash x becomes 12 by 5 into x cube plus 1 by 3. At x equal to 2, f double dash 2 value becomes 12 by 5 into 2 cube plus 1 by 5. This is positive, this is positive. Therefore, f double dash 2 is positive. That means second derivative is positive at the point. There, as per procedure, we say that thus f of x has a minimum. Has a minimum value at x equal to 2. That's all. Stop the process. These are important problems. Mostly I covered at least three problems in each topic. You must prepare these problems 90% enough for your examination point of view. Okay. This is the last video for the third module. Now I stop here.